All right, today we're going to dive into a really fascinating new way to think about your body's internal state. And we're going to frame it using this powerful metaphor of a symphony. So let me just ask you, is your body an orchestra? I mean, for a minute, forget the idea of your body as some kind of machine with a bunch of separate parts. Instead, what if you imagined it as a collection of musicians? Each one playing its own part, but all contributing to this one single, incredibly complex piece of music. That's the big idea we're going to unpack today. So here's how we're going to do it. First, we'll get into this whole body as an orchestra idea. Then we'll actually meet the musicians, our organs, and see how scientists are listening in. After that, we'll look at a pretty amazing test for improving that harmony, and we'll wrap up by asking if your body might just have its own unique biological fingerprint. And let's be clear, this whole thing isn't just a nice metaphor. It's actually a new scientific framework for listening to our bodies. It's designed to help us understand the entire system at once, instead of just looking at isolated parts. Just picture it. Your heart is the drummer, laying down that steady, constant beat. Your brain is crafting the melody with all its complex waves. And your lungs? They're the woodwinds, breathing life and rhythm into the whole composition. Each one has its own pattern, but the real question is, are they all playing together in harmony? Now, it's really important to get this straight. The researchers behind this make it crystal clear. They are not making any medical claims. This is pure biophysics. It's all about understanding the symphony of signals, not about trying to diagnose why it might be out of tune. Okay, so if the body is an orchestra, who's actually in the band? Let's meet the key musicians and see what instruments they're playing to create this whole symphony of signals. So this table kind of breaks it down for us. The heart, that's our drum, with its steady beat. The brain is on melody, with those complex brain waves. The lungs are the woodwinds, creating this branching, almost fractal rhythm. And then you've got the autonomic nervous system. That's the conductor of the whole show. And these technical terms you see, like torus and Kleinbottle, don't worry about those. They're just the mathematical shapes that scientists use to model the unique rhythm of each signal. And what's so cool about this, what makes it so powerful, is that you don't need some futuristic sci-fi technology to do it. Scientists can actually listen in on this orchestra using pretty standard, even consumer-grade tools. Things like an EKG for the heart, an EEG for the brain, or even a simple respiration belt for the lungs. So, we've got all these musicians, and they're all playing. But here's the million-dollar question. How do we know if they're actually in sync? How do you measure the harmony of the entire orchestra all at once? Well, this brings us to the star of the show, a concept called row sync. You can think of it as the ultimate harmony score. It's one single number that boils down all of that incredible complexity to tell us simply how well the body's different rhythms are working together. And to get that score, scientists measure the coherence between key players, like how the heart and lungs are syncing up. They look at the connection between brainwaves and breathing. They measure the conductor's influence through things like heart rate variability. Then they take all these different connections and basically aggregate them into that one powerful row sync score. Now, a score is just a number, right? It's only useful if it actually means something. So the researchers designed this really elegant experiment. You can think of it as the orchestra's first big rehearsal, to see if they could actually influence that harmony. The question they wanted to answer was incredibly straightforward. Could you give the body a simple instruction, a new tempo to follow, and measurably improve its overall coherence? And here's exactly how they did it. First, they measured the harmony score while someone was just sitting at rest. That's the baseline. Then they gave them one simple instruction. Breathe slowly and steadily at a very specific rhythm, about 6 breaths a minute. It's kind of like the conductor tapping the music stand and giving the whole orchestra a new, steady tempo to follow. And to prove that it really worked, they didn't just hope for a good result. They set a very clear, predefined goal. The experiment would be a success only if that harmony score went up by at least 20%. No wiggle room, just a clear target. So what happened? Well, the results were a huge success. This chart says it all. The harmony score didn't just hit the goal, it jumped well over that 20% mark during the paced breathing. The orchestra listened to the conductor, and the music became way more coherent. It worked. Okay, that is a massive finding. But it brings up another, maybe even more interesting question. Is this harmony score just a random snapshot in time? Or does each and every person have their own consistent, unique sound, like a physiological fingerprint? So, to answer that, they designed a second experiment. This one was focused purely on reliability. The whole point was to see if a person's unique pattern of coherence, what they call their row signature, is actually stable and repeatable over time. And the method was super simple, really. They measured a person's signature score on one day, and then they just had them come back within a week to measure it again under the exact same conditions. I mean, if the signature is a real thing, the two readings should be almost identical, right? To measure how consistent it was, they used a statistic called the intra-class correlation, or ICC. But all you really need to know is that it's a score from 0 to 1. A score close to 1 means your measurement is incredibly stable and reliable, like a true fingerprint. And once again, they set the bar high, really high. They weren't just looking for any old correlation. Their goal was an ICC score of at least 0.85, which in the world of science is the benchmark for excellent reliability. So by meeting both of these ambitious goals, this research established something truly profound. We now have a new, reproducible, and non-invasive way to actually quantify the body's systemic harmony. And we have really strong evidence that each of us has our own unique and stable physiological signature. So this all leaves us with a pretty fascinating final thought, one that brings this all back to you. This isn't just some abstract science. It's a whole new lens for looking inward. And it makes you wonder, if you could listen in right now, what song is your body playing?